So as I said in the beginning, let's say there's 5 types of cancer that you want to model. Or let's say that the answers are yes, no, and maybe. So there's three choices, right? Or didn't occur, unclear, or and unobserved, or blue, red, green, yellow, purple. So any any data that is categorical is not continuous, right? Did occur is not half of didn't occur, and blue is not half of red, but there's more than 2 options, okay? And then there's also count data. So for example, the continuous data could be dollars gained from number of from ice cream sold, and then count data could be actual ice cream sold. And so this is non-negative integer valued. So this could be 0 ice creams or 3 ice creams, but I'll never get square root of 2 ice creams sold, right? So these are or number of events in a given time period. For example, number of flights coming out of San Francisco today. And so we have these 3 types of outcomes that we're going to deal with. We already, on top of the continuous one, we already know how to deal with the continuous one with linear regression. And also covariates can also be classified in the same way. All right, so let me stop here, and we can continue tomorrow. Any questions?
I have a question. I'm off for speaking. So what does, like, I know what a continuous one is, I know what a local. So what is,
sorry?
What's a discrete, like what's an example of a discrete, type, variable type?
So discrete could be the count data, right? So for example, yeah, I might have, so let's change our previous example of for money gained from ice cream sales, okay? So you can use you can use linear regression for this continuous outcome because you can gain $3.5, right? But you will, you can't sell 3.5 ice creams, right? If you take the ice cream as a unit, or let's say number of flights. So flights is count data because there's never going to be 3.2 flights taking off from San Francisco. There's either going to be 3 or 4 flights, right? And so these can be something that's discrete, a discrete outcome. Does that make sense?
So it's just like the count?
Yeah, count is discrete. So discrete is non-continuous. I mean, binary and categorical, like you could also think of that as discrete. So discrete is kind of a more general term for non-continuous. Yeah, you can like formalize it much more, but that's kind of out of the scope for this course. But I think what you can kind of understand it as is there's continuous data where you can use a regression. And then for discrete data, there's binary where you can use logistic regression, which we'll cover that tomorrow. You can use, there's categorical data where it's one out of like C categories, let's say. So it's either yes, no, or maybe, or there's 5 types of cancer, right? And then there's also count data, where in count data, you do have ordinal, like an ordinal relationship, right? So 2 flights is actually half of 4 flights, right? So they're like, those are integers, but you will never have 3.5 flights, okay?
That makes sense. Thank you.
Sure. Any other questions?
I have a question.
Yep.
So when factoring in your continuous, when determining if your outcome is continuous, do you also factor in the fact that, like, for example, you're using ice cream and it's technically a finite amount, you don't have like an infinite amount of it. So how would you factor in that when trying to determine your continuous, if your outcome was continuous or not?
That's a great question. There's a few ways of doing that, but it's not so if your data looks linear, such as we had at the beginning of the slides, it doesn't really matter that you're never going to sell 1 million ice creams or 100,000 million ice creams. So because so you can still fit a line, even though you're like theoretically accounting for that. But since you're never going to actually do that, you'll only be predicting within your data range, right? So that for the temperatures that you've observed, you'll observe this finite amount of ice cream sold. And that's going to be like the range where you'll feel comfortable using this line. There's a few ways to get around that, but we're not going to see those. If you're interested, I can like give you material, definitely. But the like short and maybe a like simplified answer is it doesn't really matter, because it will only be predicting in the range that we where we actually observe data, which is very important, not to like extrapolate. So we wouldn't know if the temperature got to 118 degrees and we only observe data from 60 to 100, let's say. We shouldn't feel comfortable using that model to predict the ice cream sales for 118 degrees, right? And it's probably not going to grow linearly anyways. And so it's important to know that the prediction should be made within the range of the observations.
Okay, thank you.
Yeah, sure.
That's my question.
Yeah, no problem. So I'll see you tomorrow morning again, and we can start with more questions, but I want to give time to Zebin for the programming exercises today. So thank you.
Thanks, Aaron.